Alright guys, so let's do machine learning. So what we are going to learn today is I created this notebook. So to deepen my understanding, I started to look into how algorithms work behind the scenes. So previously what I did was just imported the learn machine learning algorithms, fitted some data and got the desired output. But as I wanted to dive deeper into it, I tried to do it with my own hands. So that's what I did, and I'm going to share it with you. So first of all, I took linear regression. So we are going to implement that linear regression in pure Python, at least, or else we can say with help of NumPy and pandas we'll do it. So linear regression from scratch, and first of all let me show you a great thing. We can implement HTML in Jupyter Notebook cells. So first of all, convert the cell into a markdown and write some HTML code, and boom. So that's what I did. I styled it with brown color. You can change it. So back to machine learning. To learn or understand or solve linear regression, we must know what is the equation of the line, the slope, intercept, mean squared error, differentiation, uh, with correct spelling obviously. And here is a good source, StatQuest video. They are always good.
Estimate them.
So
Estimate them. For example,
for machine learning and statistics videos, do check out this channel. He has so many great videos on machine learning and statistics explained in easily manner. Like he says, clearly explained. He clearly explains very complex topics. At least when he explains, it doesn't seem complex at all. Okay, moving forward. So what is the equation of the line? Equation of the line is mx plus b, or we can say here b0 plus b1 into x1. So what is this? This is a dependent variable and this is independent variable. What do we mean by that independent variable? That means by the help of x, and these are some parameters that we can tune to define the relationship between x and y. So with the help of this variable, independent variable, we can predict this variable which is dependent. This is dependent on this variable. So that is the relationship we have to find by tuning these parameters. So this is intercept, and this is oops, this is slope, and this is intercept. Okay, and we'll obviously got we will further explore these concepts. What is the slope? Slope is this, and intercept is this. Slope of the line. What is the slope of the line? What is the formula of the slope of line? Let's search on slope. Very nice. Slope of line formula. So rise upon run, y2 minus y1 upon x2 minus x1. Let's say there are 2 points here and here. So y coordinate of this point and y coordinate of this point, minus y2 minus y1 divided by x coordinate of this point minus x coordinate of this point. So that will be our slope. That is this m. And what is this b? B is this intercept. So what this b, this intercept define is, if the x is 0, so y will still have some value. Okay, so if b is not there and x is 0, so that means our y becomes 0, our dependent variables becomes 0. So what I did is I divided this linear regression into 4 parts. So in this first part we are going to solve linear regression without this parameter. So y is equals to mx is the thing by which we are going to solve with linear regression. What that means is, if x is 0, y will be 0, and that obviously means the regression line will pass through the origin. Okay, so we'll get to know more about this by seeing the implementation. So first of all, let's import some important libraries, NumPy and pandas and matplotlib for visualization. So we have created a data frame with independent variable x, which is this, and dependent variable y, which is this. I hand coded them, and let's see what they look like. So this is x, 1 2 3 4 5 6 7 8 9 10. Okay, and so there are respectively y values. When x is 1, y is 1.7. So these are some values, and what we want to do is we want to find a relationship between x and y, so that for whatever x value we can predict the y value. So first of all, let's visualize our data. Data looks like this. With the help of scatter plot, we did this visualization. So what is this? When x is 1, it is around 1.7. X is 2, y is 4. X is 3, y is 6, like that. So when x is 4, it is 7.5. So this is, we can obviously see this is positive slope. The slope of the line will be positive. So the relation is, obviously we can see when x is increasing, y is also increasing. So they have a positive relationship. And now what we have to do is we have to fit a line between this data set. So we have to find y is equals to mx. We have to fit a line so that we minimize the error. If we fit a line between this data set, the distance between all those points from the line is minimum. Hope you understand. If not, then because I'm already assuming you already know linear regression in theoretically or intuitively. This is just the implementation part. We are going to implement this in Python. So if you understand, very nice. If not, then check out the StatQuest video. Okay. Mean squared error. So what is mean squared error? Y minus y hat squared and summation of it. So that's mean squared error. And what is that? Suppose at input when x is 2, y is actually 4. So this is the actual value of y, and this is the predicted value. Let's say we have fitted a line and it says 3. So the error will be 4 minus 3, 1, and 1 squared 1. Okay, so that will be mean squared error at that data point. Similarly, after passing all the data points, so what will be where will be the data, where will be the error minimum? So that we want to find. So what we will do is we will differentiate this equation, and then we'll try to minimize this. So how we can do that? Let's see how we can do that. First of all, this is this formula. I have written this formula in the Python. Hope you are understanding it. Why is that? So this part is simply this y. So what is this referring to? This is referring to this whole series. Okay, and what is this? This is referring to, no, this one. This one is referring to this y hat. What is y hat? Y hat is predictions, our predictions. So if the slope is something and we are multiplying it with x, so this is m into x, mx. As we already said, we are not going to consider bias or intercept here, just for the sake of simplicity and understanding. When we move further, we'll add that and create a more complex model. Okay, so then y minus y hat and squared, and then doing a summation. So that's what we are doing. So this is the formula of mean squared error. We have created a function called MSE, and then what we want to do is we want to differentiate it. So we have also created differentiated version of this, and whose explanation is given here. So what is this? Let me adjust my chair first of all. We are good now. Okay, so Mean squared error is summation of y minus y hat squared. Okay, so what we want to do is we want to differentiate this. So it is obvious that this 2 will, this squared will be here 1 upon 2 into so this term will be same, and then after differentiating this we will get m. So differentiating with respect to m we'll get x here. So this is differentiated version, and then we are setting it to 0 because we want to minimize this function. So after minimizing this, solving when this equation putting this equation is equals to 0, we will ding 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 ding, we'll find this here. The slope, or we can say m, is equals to summation xy divided by summation x square. So go through this. I'll also upload this on the GitHub and provide the link. Go through this. So this is the differentiated version, and this is the mean squared error function, and this is the wait a second, someone is calling me. Anyways, so next thing is, what is the mean squared error of, okay, so simply put this, simply we are going to do this. We are going to pass this data frame into this function. So this function, what this function will do, it will find the value of slope. So this is the value of slope when the error is minimum. So what is when the, let's also see the, no, before seeing the diagram we will see error, the mean squared error when this value is there. So it, when this value is there, the error is 7, and let's put some other value. Let's say we say slope of the line is 3. So what will be the error then? Oops, it shoots to 371, see that. And if the slope of the line is 1, the error is 413, let's say 1.5, 1.4, 158. So we can see it is getting low. We'll say 1.6, 77. Okay, as we are getting closer, the error is getting low. Okay, so 1.8 the error is. So this equation found the minimum, the slope where the error is minimum. And let's finally see the diagram of it. Okay, so we can say here the line pretty much fits the data set in a very good fashion. Okay, so hope you guys understood it, and if you find something confusing, do let me know. And I think everything is pretty much covered. I'll make sure that this notebook is uploaded. Okay, thank you guys, and I'll upload as soon as possible the second part of this also, with obviously which will include this intercept also. And in another part, what we can do is we will also try to solve this linear regression with help of gradient descent. Yeah, that's it for today. Meet you in the next video.